I think without further ado, let's begin. So it's a pleasure to call on Aislinn Bohren to talk about inaccurate statistical discrimination and identification problem. And the stage is yours, Aislinn.
Well, thank you very much for hosting the conference and inviting me to participate in it. This is joint work with Kareem Hagag at CMU and Alex Emas and Devin Pope at the University of Chicago. All three of my co-authors are here today, so if you have any questions, feel free to type into the Q&A or the chat box. They're on standby and they're happy to answer away. All right, so if we look at discrimination in economics, it's been well documented that discrimination exists along many different types of group identities and in many different domains, such as lending markets, housing markets, job markets, things like that. And in the economics literature, often two potential sources or underlying factors that lead to this discrimination are posited, in particular taste-based or preference-based sources, which means that the evaluators, the people hiring the candidate or the people deciding on whether to make a loan to the candidate, have some sort of animus against members of a particular group. This is due to Becker back in 1957 as one source of discrimination. An alternative source is statistical discrimination, in the sense that there's no preference or animus against a particular group. There's just uncertainty about the productivity of that group, and therefore the group identity is informative if the groups have, say, different distributions of productivity or different links between what you observe about the group, say, for example, their signals, and how that conveys information about their productivity. So looking to the literature, Phelps and Arrow posited that discrimination may arise if you believe that one group has lower average productivity than another group. Agner and Kane looked at whether different variances in productivity could lead to discrimination, as well as more recent work has looked at whether, say, lower variance could lead to discrimination versus higher variance, and when less or more informative or biased signals of productivity will lead to this given discrimination. And so if we look at the literature in economics, most of the methods that try and distinguish between these different sources often rely on the assumption that these beliefs are accurate. So people have accurate beliefs about how productivity varies by group, how signals convey information, and then we can use the methods to distinguish whether it's these beliefs that are generating the observed patterns of discrimination or whether there's some underlying preferences. And so in today's paper, we're going to argue that often in many settings, people have inaccurate beliefs. We can look to the evidence from psychology. There's an enormous literature in psychology documenting how stereotypes and other forms of inaccurate beliefs can arise, either based on people using heuristics to form their beliefs, or people, people having some sort of misunderstanding of the environment. As well as in economics, there's been some work on looking at inaccurate stereotypes based on the representative heuristic. And inaccurate beliefs can arise from simply a lack of information. So it may be a decision that someone's inexperienced with. It may be that there's subjective information. For example, you're looking at evaluating a candidate and your signal of their productivity is stemming from a recommendation letter, which is subjective. And therefore, to interpret this, you need to understand other people's beliefs and preferences and how they're reflected in that recommendation letter. And lastly, there may be dynamics. So it may be that you understand well sort of the baseline primitive productivity distributions, but as people are hired and promoted through a promotion or promoted through a job pipeline, it may be that you don't fully understand how selection is impacting who reaches you at the given stage that you're making the evaluation. And so we're going to argue that these inaccurate beliefs, which a lot of the literature in psychology and economics have documented in certain settings, we're going to argue that these really can have a profound effect on discrimination. Why do they affect discrimination? Well, evaluators use their beliefs to learn about the trait of the candidate, for example, productivity. And so inaccurate beliefs are going to lead to inaccurate inference about the candidate. Looking to a more recent literature on model misspecification in economics, we know that inaccurate models of the world can lead to persistent incorrect learning and incorrect inference, or it can lead to also long-run inefficiencies. So even if there's a lot of information about the candidate, these inaccurate beliefs about how, say, group identity interacts with productivity could persist even in the face of many, many, many pieces of information about the candidate. Further, they may cause inefficient exit from the market. And so if, say, someone can't apply for tenure-track jobs if they don't have a PhD, then discrimination at the admissions level for a PhD or even undergraduate is going to potentially cause inefficient exit before people can even reach later stages in the market. And in related work I have with Alex Imas as well as Michael Rosenberg, we explore the dynamics of discrimination with inaccurate beliefs. So why do inaccurate beliefs matter? The focus of today's paper is going to highlight that from a methodological perspective, erroneously assuming accurate beliefs is going to lead to a misidentification of the source in a common method used to distinguish the source of discrimination in economics. So it's called an outcome-based test, which I'll talk about more later. And we're going to also show that relaxing the assumption of accurate beliefs is going to create an identification problem, and that it's going to be hard to tease out the source of discrimination when we allow for this third category of inaccurate beliefs. Why do we care about teasing out the source? Well, from a policy perspective, effective interventions when beliefs are inaccurate are going to be different than those to try and mitigate discrimination stemming from either accurate belief-based sources or taste-based sources. Second, if we want to study the welfare implications of discrimination, then understanding what that source of discrimination is going to be an important factor in figuring out what the efficiency losses are from the discrimination that's occurring. So to first make a case that inaccurate beliefs has been underlooked in the discrimination literature in economics, we did a large literature survey. We looked at 10 different journals over a roughly 30-year period from 1990 to 2018. And we tried to see how many papers studied discrimination empirically, and then within that set of papers, how many allowed for the possibility of inaccurate beliefs. So we found 105 papers that met our inclusion criteria. Within those papers, 102 of them found evidence of discrimination. So here, this is disparate treatment by group identity, some group identity, be it race, gender, sexual orientation. Many of these papers try to look for the source of that discrimination, so distinguish between, or at least discuss the possibility that it could stem from taste-based versus statistical sources, so roughly 62%. Roughly 47% tested for these two different sources to try and identify the source. So this is in general more difficult than establishing the existence of discrimination, so some papers weren't able to look at the source just simply from the data that they had available. But if they did look for the source, we showed that only about 10% of them discussed whether beliefs could be accurate or inaccurate. And even fewer, so only 7 of these papers, or roughly 7%, tested for inaccurate beliefs to see whether this belief-based source of discrimination could be from inaccurate beliefs rather than accurate beliefs. And a similar number of papers also tried to measure beliefs in some way. So this is the list of papers that we looked at, as I said, between 1990 and 2018. As we can see, only a very, very small subset of these papers that empirically studied discrimination allowed for the possibility of inaccurate beliefs. And further, most of these papers are in the past couple of years. So they're mostly relatively recent work that's trying to look at inaccurate beliefs and discrimination. So next I'm going to present a simple model of discrimination with inaccurate beliefs to try and understand how it impacts what types of discrimination we observe, and then try and get a sense of what we'll be able to say about the source when we allow for the possibility that discrimination may also arise due to these inaccurate beliefs. So let's take a simple model where there's a worker. The worker has some group identity, either M or F, which is something that is observable. Their worker has some unobservable productivity, which is normally distributed with a group-specific mean, mu g, and a group-specific precision, 1 over tau g. And then the worker generates some signal of this productivity, be it from an interview or a recommendation letter, a test performance, a GPA, something like that. This signal we also assume is normally distributed. So it's the productivity with a mean 0 error that has also a group-specific precision, eta g. And so just without loss of generality, we're going to focus on discrimination against group F by an evaluator. So an evaluator is going to decide whether to hire the worker. 0 corresponds to do not hire, 1 corresponds to hire. And here where we differ from a typical model is that we allow the evaluator to hold subjective beliefs about the worker's distribution of productivity as well as signal precision that may differ from the true beliefs about the productivity, or the true distributions of productivity and true signal distribution. So to denote the subjective beliefs, we use a hat to denote these parameters. Mu hat G is the subjective average productivity. Tau hat G is a subjective belief about the precision of productivity, and eta hat G is a subjective belief about the signal precision. And so this is a misspecified model when the subjective parameters that the evaluator holds differ from the true underlying parameters for that group. So the evaluator observes the group identity and the signal generated by the worker, and then uses Bayes' rule to update beliefs about the productivity A. So importantly, we're staying as close to Bayesian learning as we can. The evaluator is using Bayes' rule. It's just that they may potentially have incorrect beliefs about these underlying distributions. So we're not imposing any sort of heuristic. We're just saying, we're just taking these beliefs as given and then assuming that in all other ways the evaluator is going to update according to Bayes' rule and learn about the productivity of the candidate. So the evaluator, we're going to assume we're going to use a reduced form representation of the evaluator's preferences. The evaluator will hire the worker if the subjective posterior, given the evaluator's beliefs, is above a group-specific hiring threshold, UG. And so we could just think about this as the evaluator wants to hire candidates of expected productivity above a certain level. And we're just going to use essentially, we could think about a payoff that depends on the productivity, and then use this reduced form representation to just say this is how the evaluator's preferences are going to be reflected in the hiring decision. And so the evaluator's type consists of her preferences, UG, as well as her subjective beliefs about the relevant parameters for the worker's distributions. All right, so we want to distinguish between properties of the model primitives, which we're trying to identify, and properties of observable behavior, which is what we see, and then try and back out the underlying causes of that behavior. And so in order to do that, we use partiality to refer to properties of the model primitives, such as preferences and beliefs. And then we use discrimination, which is a property of behavior. It's going to correspond to the treatment that the worker receives based on the evaluator's underlying model primitives. So what we refer to as preference partiality is an evaluator who has different group-specific hiring thresholds for group F and group M. UF is not equal to UM. And belief partiality is an evaluator who has different beliefs for group F and group M. So this could be different beliefs about average productivity, different beliefs about how dispersed productivity is in the population, different beliefs about how precise the signal is, or some combination of the three. Beliefs are accurate if the subjective beliefs are equal to the true population distributions, and otherwise they are inaccurate. And so these are the model primitives that we're going to be interested in trying to identify. And what we observe is differences between hiring decisions for members of different groups. So we let D of S theta denote the difference between the optimal hiring decision for a worker from group M who generates signal S and the optimal hiring decision for a worker from group F who generates signal S for an evaluator of type theta. So importantly, when we look at discrimination, we want to hold constant what the evaluator is observing about the candidates aside from group identity. And so it's important that we hold constant. We compare members of group M and group F who generate the same signal. So we're not trying to say if different groups have different distributions over signals, then they're treated differently because we're, for example, seeing groups with higher education, candidates or workers with higher education from one group than another. We want to essentially compare workers who have the same education, the same GPA, the same SAT score, things like that, and see if they're treated differentially just only due to their group identity. All right, so we say discrimination occurs against group F if there exists a signal at which D of S theta is equal to 0. In other words, if there exists a signal at which the worker from group M is hired when they generate that signal, but the worker from group F is not hired when they generate that signal. So as a first pass, we're interested in when different sets of beliefs and preferences give rise to the same discriminatory behavior. And therefore, we define what we call equivalent discrimination. We say two evaluators of types theta and theta prime exhibit equivalent discrimination if they exhibit the same level of discrimination on all possible signals that workers can generate. So in other words, two types, one could have, say, differential beliefs about different groups, another could have different preferences over the two groups, but as long as they make the same hiring decisions for each group at all signals, those evaluators are going to exhibit what we call equivalent discrimination. So our first result is going to be a characterization of the set of types that exhibit equivalent discrimination. Given that the posterior mean productivity is monotonic with respect to the signal, we can represent the optimal hiring decision for the evaluator as a cutoff rule with respect to the signal. In other words, they hire a worker if they generate a signal above some type-specific and group identity-specific threshold S bar. And from this, we can see that if two types of evaluators had the same signal cutoffs for hiring members of group M and members of group F, then they're going to exhibit equivalent discrimination. In other words, they're going to discriminate on the same set of signals against group F. All right, so we have here a characterization of that set of types, but I think it's a little easier to see in a graph, so I'm going to skip to the next slide. And what we do is we think about sets of types that exhibit equivalent discrimination as what we call isodiscrimination curves. And so here we have, we're holding constant most dimensions of the type. Here we have on the x-axis the evaluator's perceived average productivity for group F. Here on the y-axis we have the preference parameter for group F. And each of these curves corresponds to a set of types that would exhibit the same level of discrimination. In other words, the same differences in hiring thresholds for members of group M and members of group F. So we're holding fixed here the evaluator's beliefs about group M, as well as the evaluator's beliefs about the concentration of ability and the signal precision. But of course, this isodiscrimination curve would, you could represent it in more than 2 dimensions to consider these other parameters as well. And so taking a look at this right here, we have the red line corresponds to the set of types that would exhibit no discrimination. In other words, they would treat group M and group F identically. And as we increase and move in the northwest direction here, we're moving to isodiscrimination curves with increasingly higher levels of discrimination. Now, over here in this quadrant between the dotted blue line and the dotted green line, these are evaluators who would both be have a lower perceived average productivity for group F that would generate discrimination. In other words, they think that on average, members of group F have a lower productivity than group M, and they also have some sort of preference against group F. So they have some sort of animus towards this group, which leads them to have more stringent hiring conditions. We could also have, say, more extreme down here in this quadrant below the dotted blue line and to the left of the green line. We could have more extreme belief partiality in the form of lower average productivity, but we could have it be somewhat offset by preferences that slightly favor group F. So that would be types down here could also exhibit equivalent discrimination. And of course, the other way around as well, we could have, say, beliefs that actually favor group F, but a really strong preference against group F, which up here to the right of the dotted green line would lead to types that would discriminate against group F because their preference parameter more than offset their more favorable beliefs. And then here we can also look at things like belief neutrality. So this dotted green line would be a type where it intersects this top isodiscrimination curve would be, say, a type who exhibited this given level of discrimination, had the same beliefs about average productivity for the two groups, but a preference against group F. And similarly, the dotted blue line denotes preference neutrality. So same preferences, no preference partiality against a group, but pretty strong beliefs that the group F has lower average productivity than group M. And so we're going to use this type of graph to go through different common designs and see what can we say or try and say more about what are the underlying preferences and beliefs that are generating a given level of discrimination. All right, so identifying discrimination, we want to know, can a property of interest be backed out from available data? In the context of this paper, that means when evaluators may have inaccurate beliefs, what can we say about the preferences and beliefs and common empirical designs that are used to study discrimination. So as a first thing that papers often look at, as we saw in the literature survey, is the existence of discrimination. That just simply means showing that there exists a signal such that D of S theta is greater than 0. In other words, a signal at which group M workers are hired and group F workers are not. If we assume that, in general, the researcher will observe group identity in the hiring decision for each worker when they're studying discrimination, if the researcher also observes the signal, then it's straightforward to identify this existence. This would just be a direct way to observe it. Often this is not possible, but correspondence or audit study methods have been used where you create fictitious workers and randomly assign gender and signal to these workers. And so essentially that just boils down to observing S in this fictitious sample of workers. So it's pretty well known in the literature that correspondence and audit study methods can identify the existence of discrimination. That's not really the focus of our paper. Provided the observed hiring decisions are for a sufficiently rich set of signals, you can think about it as also identifying the isodiscrimination curve. That's really a measure of how much discrimination exists. And so really we're gonna proceed from a place where we already know from correspondence or audit studies that it's relatively straightforward to identify the isodiscrimination curve. So what we're really interested in is what can we say about the source of discrimination when we can, at a minimum, observe the isodiscrimination curve. By source of discrimination, I mean what forms of partiality generate the observed discriminatory behavior. So the first thing we can say is that observing the isodiscrimination curve, but nothing else, doesn't allow the researcher to distinguish between preference and accurate belief-based partiality. We know this from several papers that already exist on correspondence studies. Further, it doesn't allow the researcher to say anything about inaccurate belief partiality. And our result, looking at the characterization of the set of types that exhibit equivalent discrimination, allow us to say that actually it's not even possible to rule out any of these potential sources. So our next result shows that each form of partiality in isolation can generate a given pattern of discrimination. For any type that discriminates against group F, there are going to be a continuum of types that exhibit equivalent discrimination, including a type who only has preference partiality, a type who has lower perceived beliefs about the expected productivity, a type who has higher perceived concentration of productivity, a type who has a lower perceived concentration of productivity, and similarly for signal precision. So really just observing the isodiscrimination curve doesn't allow us to rule out any of these potential sources. We essentially, we can say that it doesn't stem from preference neutrality and higher expected productivity, obviously, but it could stem from lower expected productivity. It could stem from different preferences. It could actually stem for either higher or lower concentration, depending on how the type perceives the market. In other words, perceives the hiring threshold relative to the average performance of the market. So again, I'm going to jump to a graph to illustrate this. What this result is basically saying is that any given isodiscrimination curve, so let's suppose the researcher identifies this isodiscrimination curve here. Again, this is perceived average productivity on the x-axis, preference parameter on the y-axis. Let's suppose the researcher knows they're here. This isodiscrimination curve is going to intersect all 4 lines of where there's just a single source of discrimination. So in other words, it intersects this line of belief neutrality for perceived average productivity. It intersects the line of preference neutrality. This is this red asterisk type right here. Coming over to the graph on the right, we have the perceived concentration of productivity, and we can also show that it intersects the line of belief neutrality for perceived concentration, preference neutrality as well over here. So it could just be generated by this perceived concentration. So what this tells us is that this isodiscrimination curve is really, it's not going to give us very much information about what is driving the source of the discrimination. All right, so turning to what we want to look at next is we want to say, well, what about other methods that were used under the assumption of accurate beliefs to try and distinguish the source of discrimination? So let's now—
Aislinn, sorry, just one question. So you're assuming that we can observe the isodiscrimination curve because the idea is that I can, through these experiments, observe what is your signal threshold for—
Yeah, so we're assuming that you can at least identify the isodiscrimination curve. And so as we showed before that, if you observe the hiring decision and the group identity and the signals generated for different workers, then you could observe, think of it as you can observe the level of discrimination.
Okay.
Right, so you see, you can see the different hiring thresholds, or if you wanted to do analogous analysis for, say, a different type of decision with like a 5-star rating, you could observe the ratings. So you know the level of discrimination, and now we want to say what underlying preferences and beliefs are generating that level of discrimination.
Perfect. Thanks.
Okay, so a common method to do this is what's called an outcomes-based test. Let's suppose you could observe the true productivity and signal distributions for each group. Then, under the assumption of accurate beliefs, this would identify the evaluator's type. Back in our figure of the isodiscrimination curve, if evaluators had accurate beliefs, let's suppose here we had, say, an average productivity of 5 for group M, an average productivity of 4.5 for group F, then imposing this on the graph, we'd see that the line of accurate belief partiality, this vertical red dotted line, intersects the isodiscrimination curve at a unique point. So this asterisk right here would be the type that's identified if the evaluator had accurate beliefs. But importantly, this identification crucially depends on the assumption that the evaluator has accurate beliefs. If inaccurate beliefs are possible, the type is no longer identified. And further, it really doesn't help us say anything, because looking at distributions, the true distributions, isn't going to give us any information on the evaluator's inaccurate beliefs. So next, what we take a look at is, well, what's going to happen if this common outcomes-based method is used to identify the source of discrimination, but evaluators actually have inaccurate beliefs? So our next result shows that erroneously assuming accurate beliefs is going to lead the researcher to misattribute discrimination from inaccurate beliefs to preferences. Further, if let's say what the evaluator observes is there are no, say, let's suppose no difference in the distributions, then inaccurate beliefs and preference partiality can actually be mistaken for accurate beliefs. So coming back here, we can see that if, for example, the evaluator here, we impose accurate beliefs, but actually the evaluator had, say, more extreme inaccurate beliefs, then that's going to just be, if we impose inaccurate beliefs, that would correspond to a preference parameter of, say, 6.2 if the evaluator's beliefs were 4. But if we erroneously impose accurate beliefs, that's going to identify a more severe degree of preference partiality, 6.3. And so therefore, an intervention might try and target this more severe preference partiality, when in actuality, it's really these inaccurate beliefs that should be corrected in order to try and mitigate this discrimination. All right, so our next result shows that if a researcher incorrectly assumes an evaluator has accurate beliefs and uses the outcomes-based method, then for a generic set of types and true distributions, the researcher misidentifies preferences. And further, if inaccurate beliefs increase discrimination against group F, in other words, relative to accurate beliefs, if inaccurate beliefs lead to discrimination on a larger set of signals, then the researcher is going to overestimate the evaluator's preference partiality. And if it decreases discrimination, then it's going to go in the opposite way. The researcher is going to underestimate the evaluator's preference partiality. All right, so let's suppose the researcher does impose this assumption of accurate beliefs, and let's suppose that we're in a world where inaccurate beliefs and preference partiality of the evaluator's true types, which are inaccurate beliefs and some sort of preference partiality, generate equivalent discrimination to accurate statistical discrimination. So in other words, if we go to this previous figure, let's suppose that an accurate statistical discriminator would lie on this isodiscrimination curve we observe, which it doesn't in this figure, but if we imagine changing beliefs, it could. So going there, we could say, well, what is an accurate statistical discriminator? That's someone who has accurate beliefs and no preferences against the group, and so all of their discrimination is stemming from these accurate different beliefs in the distribution. And so we might say, well, if the evaluator does have some inaccurate beliefs, but it's offset by preference partiality, so it leads to equivalent discrimination to an evaluator who has accurate beliefs and no preferences against a particular group, then maybe this doesn't really matter because we're seeing the same observables, so these inaccurate beliefs are innocuous. But if we think about the dynamic aspect of the decision, if inaccurate beliefs are being offset by preferences today, that doesn't necessarily mean that they will be in future performance evaluations. So they may negatively affect the worker in a way that's not equivalent to accurate statistical discrimination down the line for promotion or future performance evaluations. For example, we could think about inaccurate beliefs that exaggerate the true differences in average productivity between groups. And maybe at the entry-level position, the evaluator perceives that there's large differences in average productivity for groups, but somewhat values diversity. And so they have preferences that favor the disadvantaged group to try and offset these perceived differences in average productivity. So at the entry level, we do see some discrimination, but not as large as you would expect if it was only stemming from inaccurate beliefs. But now if the evaluator only feels compelled to favor the disadvantaged group for entry-level hiring, it may be that down the line, people are getting in the door because they're somewhat favored at the entry level, but these inaccurate beliefs are going to lead to persistently lower rates of promotion and advancement as we continue to future parts of the hiring and promotion pipeline.
Hi, Aislinn, you have 9 minutes left if you want to leave 5 for questions.
Okay, great. Yeah, I'll finish up by 1:25.
Well,
All right, so then the last thing I want to say, sometimes the one thing we can rule out is it's possible to rule out accurate statistical discrimination. So we can see, is the pattern of discrimination consistent with accurate belief partiality and preference neutrality? This is of particular interest because ruling out accurate statistical discrimination establishes that discrimination either stems from animus towards a group or inaccurate beliefs about them, rather than just some accurate underlying differences in productivity. Coming back to this graph right here, we can see that if the accurate statistical discriminator does not lie on our observed isodiscrimination curve, then it will be possible to rule them out. More formally, we can show that this is possible when the observed productivity and signal distributions for each group don't satisfy this condition. So we can say the evaluator is not an accurate statistical discriminator. We can at least rule out discrimination stemming from just simply true underlying differences in the productivity of the two groups. Okay, so I want to take a couple of minutes to focus on how can we identify the sorts of discrimination when beliefs may be inaccurate. So far, we've had a lot of negative results showing how either the outcomes-based method can't identify the source, or if accurate beliefs are imposed, will erroneously identify the source. So we also explore 2 possible methods to identify the source. One is somewhat obvious. You can just simply elicit subjective beliefs. This would be analogous to the outcomes-based method, but just simply using subjective beliefs instead of the true beliefs to identify preferences. One thing that's important to keep in mind is if you want to know whether the beliefs are accurate, you must also try and collect data on the true distributions. Often in many settings, it's going to be difficult to elicit beliefs if it's not possible to directly interact with the evaluators. So if you're just, say, observing decisions, but you can't actually try and elicit their beliefs. And so we also posit another potential method where you manipulate the information that the evaluator observes by varying the number of signal draws. An important caveat of this is that it's crucial when we open the door to the possibility of inaccurate beliefs. This identification method it's crucial that these multiple signals are drawn from the same distribution. So in other words, if we think about, say, observing a restaurant with 5 reviews versus 10 reviews on Yelp, or observing, say, someone on an online programming site observing their evaluations on 5 versus 10 programs. And that's in contrast to, say, observing things from different domains like the SAT score and the GPA. And because one's beliefs may be inaccurate, we don't really know anything about how the evaluator, say, interprets SAT score versus GPA. Maybe they think that one group receives a lot of coaching for their SAT, and so it's a more informative signal, say, for a minority group, whereas the GPA, they think there's potentially favoritism, and so they could think it's a less informative signal. And once we allow for the possibility that different signals from different domains have, say, different beliefs about how they interact with the group identity, varying this type of information is not going to allow us to really identify anything All right, so our last result shows that if you manipulate information, then there's a continuum of types that will exhibit equivalent discrimination if you say observe either 1 or 2 signal draws, but importantly, all of these types have the same preferences. So they may have different beliefs, but they have the same preferences. And so what this tells us is that there's a unique level of preference partiality that will yield equivalent discrimination across informational treatments. This holds for 2 signal draws, but this set of types also exhibit equivalent discrimination for any number of signal draws that we see. And so we can use this method to identify preferences, whether discrimination is stemming from different preferences for the different groups, but we can't use it to identify how or what type of different beliefs are generating discrimination. Is it differences about perceived average productivity, differences about perceived concentration of productivity, or the signal? And here we see from this figure, we can identify the ISO discrimination curve for 2 different signal treatments. Here we have 1 draw as the black ISO discrimination curve, 2 draws as the blue one. Then we can see that this will identify a unique preference parameter. It also looks like it identifies a unique perceived average productivity, but that's just because I can't illustrate this well in 4 dimensions. If we looked at 4 dimensions, it would be tracing out a line with a unique preference parameter and then a set of different perceived average productivities, concentrations, and signal perceptions. Okay, so in the last couple of minutes, the last component of our paper is an experiment just to illustrate how inaccurate beliefs may interfere with the conclusions we draw. So I'll take a couple minutes to go through this. What we did was we collected profiles from workers on Mechanical Turk, 400 from the US, 200 in India. We had them answer a 50-question math test and develop a personal profile with things like their favorite color, favorite movie. And then we recruited a different set of workers to be employers. They observed the profiles of different employees and decided on a maximum wage or willingness to pay to hire each of these workers. I won't go through the payment method other than to say that the employer's payoff depended on the performance of the workers on the math test. And so in other words, their beliefs about these workers' productivity is going to interact with how they were rewarded in the experiment. So we looked at 3 different group identities, Indian versus American, male versus female, old versus young. Just for today's talk, I'll focus on Indian versus American for illustration. Really, this is sort of an illustrative example rather than a market in which we think the actual discrimination is particularly interesting. So what we want to do is we want to go through this and show how imposing accurate beliefs would misidentify preferences, and then show if we allow for inaccurate beliefs, how we can potentially identify what the source of discrimination is. So as a first pass, we see that the average wage offered to Indian workers was higher than the average wage offered to US workers. The red up here is $33 on average were offered to Indian workers, slightly less than 31 was offered to US workers. So we do see differential treatment. The Indian workers received higher wages. Given the conventional methods to study discrimination, how would we test for statistical versus case-based? Well, we actually observed the performance of both of these workers. We know how many math questions they answered correctly, and so we could compare this to the true performance distribution. Here we actually see that the US workers answered slightly more questions correctly. They answered slightly more than 37 on average versus slightly less than 37 for the Indian workers. And so if we were using the outcomes-based method and imposing the assumption of accurate beliefs, this would lead us to conclude that there's case-based discrimination against the Americans. They received a lower average wage, but they had a higher average productivity. All right, but what if beliefs are wrong? So what if the evaluators didn't have correct beliefs about the performance? So to test this, we asked the employers, on average, how many questions do you think that each group answered correctly? We provided incentive-compatible bonuses for performance on these questions. And we then could also impose these beliefs to see how they compared to the actual wages offered in the hiring decision. So over here, we see that, again, the dotted line is the actual performance. Over here, we see that the perceived performance for Indian workers was higher than the perceived performance for US workers. And when we allow for these inaccurate beliefs, we see that actually we have inaccurate statistical discrimination against Americans, not case-based discrimination. All right, so we next said, all right, I'll just finish up in a minute, so I have time for questions. we next did an intervention. Is it possible to correct beliefs? So if we know that discrimination is stemming from inaccurate beliefs rather than, say, a taste-based source or true differences in productivity, then one possible intervention is to provide people with the accurate distributions of productivity and how they vary by group identity. So we said, here are the correct answers for the belief questions you answered. Americans answered 37 questions correctly on average. Indians answered 36.5. And then we had these employers make wage offers on 10 additional employee profiles. So taking a look over here, we see that in this third panel, the hiring decision after they were given accurate beliefs, there's less discrimination, there's less differential treatment between the two groups relative to the first hiring decision. So we see some of the discrimination stemming from inaccurate beliefs did disappear. We do still see differences, and we do still see Indian workers being paid a higher average wage than the American workers, even though the performance is in the other way. So either there's still some taste-based, there's still some inaccurate statistical discrimination, but we were able to move beliefs with this intervention, so we were able to partially correct for it. All right, so in conclusion, we argued in this paper that inaccurate beliefs may be prevalent in many domains currently being studied by discrimination researchers. Most tests that try and separate statistical and taste-based sources rely on a strong assumption that people hold accurate beliefs. We showed that ISO discrimination curves can prove a useful modeling tool or way for thinking about how different preferences and beliefs can map into equivalent levels of discrimination. And then within this framework, we can show that incorrectly imposing the assumption of accurate beliefs can lead to mistaken attribution of source and therefore misguided policy and welfare analysis. But relaxing this assumption generates an identification problem in the outcomes-based method. And so we then posit other methods that could potentially at least somewhat disentangle the different sources when people may have inaccurate beliefs.
Okay, so maybe if you are close to done, maybe we can open it for questions. Aislinn? Hello? Can you hear me?
Yeah, I can.
Yeah, can you hear me, Marina? Yeah.
We can hear you, Pradeep. Yes, I think Aislinn is done, so we can see if there are questions.
So are there questions? I have one, very much provoked by your comparison of US and Indians. So the question is this, it relates a little bit to the talk by Bob Bauman. You have a sample in a particular area where you are looking at Indians versus American performance, but people's beliefs are maybe formed on a much bigger arena where they are looking at different fields, and there the belief is not inaccurate if you extend the arena over which they are looking. And as a rule of thumb, therefore it's convenient to have a simple belief about the Indians versus the Americans, though it may be false in certain special areas. So how would you respond to that explanation, which would be Bob Bauman's explanation?
I think that's exactly one of the sources of inaccurate beliefs I highlighted in the introduction, in the sense that you may have accurate beliefs about, say, on average, how a typical person in the US would perform in the math questions versus a typical person in India, but you don't know about the subsample on Amazon Mechanical Turk.
Right.
And so in that sense, inaccurate beliefs can arise even if you have a pretty good understanding of population averages, because you don't know about selection of the particular problem at hand.
I know. Okay. Any other questions? Thank you. Any other questions? Well, we have just 1 minute left for transition. So thank you very much for a very stimulating talk.